I'm going to turn this real Lego set into a fully playable Lego game. Not a game with a Lego skin, not a mock-up, a Lego game built brick by brick from the ground up. They were a massive part of my childhood, simple but endlessly fun. Now, as a game developer, I've realized that simplicity is an illusion, and making a game feel like a Lego one might be far harder than it looks. They've been refined for decades by huge teams. I'm doing this alone. I'm putting my skills to the test, breaking down what makes a Lego game work, and together we're going to find out whether I can actually pull it off. The first step to turning a Lego set into a game is to build it. And whilst putting my Lego building skills to work, I'm wondering where you even begin in turning a real Lego set, in my hands, into a playable game. To start, we need a digital version of the set. I'm going to use a piece of software from Bricklink called Studio 2.0, which allows you to build Lego digitally, and as part of it, import instructions of Lego sets. And as I'm building this Lego set, I'm starting to piece together the basis of an idea. Christmas Eve, a crashed vehicle stripped of its parts, and a mission to get them back. We'll leave the idea broad and basic for now because the question remains, how do you build a game from this? I believe it comes from 5 key pieces, 5 bricks. The first piece we're putting down is the character, the heart of every interaction. I grab a minifigure from a website called Mecha Bricks, but there's already a problem. I'm not very good at rigging or animating. It is one of my weaknesses as a developer, and now I have to face it. But I've gone searching high and low for anything which could help me, and I found a minifig rig. A rig specifically made for minifigures. I'm in luck. But after taking the time to do a few animations and experiment with it, an even bigger problem emerges. It doesn't look right. It doesn't feel right. The rig is designed for it to move like stop motion, rigid limbs, rigid movement. And after carefully watching Lego game content, it's clear that the animation style uses bendy limbs. They break realistic motion in favor of character, personality, and bounce. The first of our 5 key pieces, and there's already big problems, but we're just getting started. I'm going to have to face my weakness head on. But I have a secret weapon, or not so secret weapon, and you do too. It's called reference. I recorded footage of me playing a Lego game where I can take my time in breaking down the poses and analysing the content. I know the tools, although I don't rig or weight paint much because who likes doing that? But I know the software, and with great reference, surely that's going to take me quite far, right? I'm approaching the animation in a pose-to-pose workflow. That means I find the key moments of the animation, move the character into that pose, and then adjust the frames in between to get the right movement, momentum, and timing. And after hours of setup and animating, I have animations. They aren't perfect, but they do have some personality, and they represent the character actions well enough. This felt like a roadblock, something which could have held the whole project back. So to have these animations really feels good, and very importantly, it's broken down that mental barrier of feeling like I can't really do it. And it's a good job that I am feeling more confident, because I need to address the jump animation. This is where the lack of experience comes in. I have it as one animation, meaning the timing is baked into the animation. After 2 seconds, the animation will land. But what if I increase the height of the jump and therefore I'm going to land after, 3 seconds? There's no flexibility. That could be a problem down the line. Back into Blender I go to make a jump start, jump fail, and jump land animation. Can tie these into events which run when I press jump, when the character is detected as falling, and when the player hits the ground. And therefore, I now have flexibility in changing the way the jump works. Already, the mindset shift, the feeling of can and not can't, is paying off. We have our elf character running, jumping, punching, and eagerly awaiting to build something. And it's all being viewed from a fixed camera angle. But that's typically not how Lego games work. Going around a corner, changing floor, entering a tighter space, it follows you smoothly. It's dynamic. However, I can't figure out how they do it. I have a theory that it might be on a predetermined rig based on the character's position in the level, but that to me sounds a little complicated, and I like solutions which don't hurt my head too much. A simple, customizable solution could work. I created an event on the player to rotate and zoom the camera boom over a timeline. These all have editable parameters for how much you rotate, zoom in, the speed at which it happens, etc. I can set up a blueprint volume with these variables exposed, which can call the event on the player and therefore change the camera when overlapped with. So one volume may be set to move to the right by 10 degrees, whilst zooming in 200 units at 0.5 times speed. Another volume may do the opposite. You get the idea. The core of the dynamic camera is there, and there's control over where, when and how it happens, but it isn't an overcomplicated solution. So there we have it, a moving character and a moving camera, and the belief that this crazy project might just work. The heart of LEGO is to build, to create, and the games are no different. So I need to understand, mechanically, what actually is building. I need a workflow to bring LEGO into the engine and make it function in a modular way. We're creating a pipeline, a system, because without one, things could get out of hand very quickly. Building is the process of going from parts to an object, and the opposite from object to parts would be destruction, so it feels important to handle these as two separate blueprints. Now comes the challenge of building a system that smoothly converts between the two with any parts. But before we do that, we need to test getting some LEGO in engine, and if you thought that would be a simple process, you would be wrong. There's a lot of cleanup and preparation going from Studio 2.0 to Blender, but there is a consistency to the process, meaning it's repeatable and reliable. We're starting to see a workflow forming. Now that we have a few parts in here to make a bench, I can get into the heart of the work and start trying to bring it to life. Just like LEGO is made up of pieces, so is a game. And in our case, one of those pieces is going to be an actor component. This is essentially a modular piece of logic which can be added to any actor. So if we make an actor component for building, we'll be able to add this to any actor with LEGO meshes in it. Inside my building actor component, I start by simulating physics for any static mesh components found, because we need to let the player know what is and isn't buildable. The way LEGO does this is by having them bounce. So I set up logic which will apply a gentle force to the parts to bounce them up and down. When we build LEGO, we are told by an instruction manual where pieces go. So we move the pieces from where they are to where they should be. I believe the same process can be done here. We just need to tell the blueprint where the LEGO pieces should go. Within the parts blueprint, we can manually put them into their built formation. They are still individual loose pieces, but their default position is the correctly built form. A time-consuming process, but hopefully worth the effort. So before any physics or impulses are applied, we can store that transform. That transform is where the piece should go, and a map variable lets me associate a piece with a location. This is our instruction manual. With this information, we can cycle through each part and move it from wherever it is to its build position. Tie this into a blueprint interface event, which is triggered by the player pressing the build button, and combined with our animation, we get building. But there's more to it than that, because what if you stop building partway through? We need to track the player's progress whenever a part is moved, and we can do this via a couple of integer values. The first variable simply counts parts. It will go up by 1 each time a piece is placed, and we can use this to essentially act as a checkpoint. So if we build up to part number 3, stop, and then build again, the array will be accessed at part number 3 and continue. The instruction manual approach and consideration for the user experience means we now have building, a huge step forward and an iconic part of any LEGO game. Now I can take any pieces, like these ones over here, and use them to build an object. And oh, would you look at that? I just built today's sponsor. Which is ironic because Brilliant can help you to build real knowledge about a variety of topics. Where we are using LEGO pieces to turn into an object, Brilliant will turn you into a better problem solver. Brilliant is a platform which helps you to excel in maths and computer science, with visual interactive problem solving and personalized practice. You'll see how the computer science courses gradually build your knowledge through personalized learning, which ensures you're advancing at your ideal pace. It can take something as complex as programming and show you that you can do it. You can start thinking like a programmer. With the library of expertly crafted courses having doubled in 2025, now is as good a time as any to start learning. By using the QR code on screen, you can start learning for free on Brilliant for a full 30 days. And you can take advantage of 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. Go check it out and see for yourself. And back to the LEGO. This building process spawns the intended object blueprint, in this case a bench. And now that we have a LEGO bench, there is only one natural thing we want to do with it. Destroy it. With building comes destruction, and with destruction comes building. So let's balance things out. I'm going to create an actor component called BPC score health. Each object which can be destroyed essentially has health. Like when a player hits 0 health, they die, the object has 0 health and dies, but the death logic is to spawn parts instead. To do the hit, I'm going to set up a basic punch. It's just the animation we made earlier and a sphere trace for testing purposes. We'll expand upon this later when we dive into combat. I had a little scale change. Sorry, no, I said little, not massive. I had a little, thank you, scale change to the object via a timeline, so there's a bit of a bounce to being hit. It's reusable across all objects, and it introduces some feedback to the player's action. And this is working, right? You hit the object, it eventually breaks into parts, it is destruction. But it's not good enough. On the back end, it's a bit messy. The logic could be cleaner, and I am questioning whether the health component is the right way to go here. But secondly, and importantly, the interaction is missing personality. It's lacking feedback and satisfaction. It doesn't feel Lego, and it's really important to me that it feels close to it. It's the purpose and motivation behind the project. This isn't it. On a happier note though, the loop of building, destroying and building again is working. That's exciting. But we need to go further. I embarked on an experimental path trying different ways to handle the feeling of destruction, because this is less about function and more about the feedback and feel. The main experiment is a system which allows for individual pieces to be knocked off before eventually flashing out of existence. And this felt pretty good. There was more response to the hit, it reinforced the idea of breaking the object apart, but it still lacks some of the personality I want. And again, the logic felt a bit messy and not easily reusable. If we want to scale up to bigger objects, more parts, more Lego, this system could fall into pieces. An idea. And it reintroduced our new friend, animation. When an object gets hit, just play an animation. It sounds cleaner to me. And therefore, I'm going to overhaul the system. 1 step back for 2 steps forward, but it might pay off. I'm going to create a new separate actor component called BPC_destructible, and here I'm going to set up a similar system in the sense that after a certain amount of hits, it will get destroyed. But there's 3 main changes. 1, each hit now plays an animation montage assigned via a variable on the component. This immediately gives some life, personality and bounce to the objects, and the logic is much cleaner. 2, I'm going to set up more variables to allow for different responses to being hit and destroyed. Objects can be non-destructible, destructible but not buildable, or, as we have been doing so far, destructible and buildable. And number 3, as a result of this, if something is destructible but not buildable, I need a different response. I don't want buildable parts to drop, but I do want feedback that the object is destroyed. This is where a new blueprint comes in, a blueprint for destruction parts. When one is spawned, it takes an array of meshes, launches them outwards, and then gradually flashes before being destroyed. It was initially frustrating trying to find the balance between the personality of a Lego game and keeping the logic highly reusable, but the step back we took, it was worth it. Now it's more versatile, more fitting with the system of importing parts and objects, and importantly, it's more satisfying. It's time to stress test everything we've built so far with a bigger object and a lot more parts. If this works, we have the system we set out to build. If not, we may need to take more than just 1 step back. I think a fireplace would be a nice addition. I go through the exact same process as before to get the Lego into the engine. With more pieces, it also meant more individual part placement. I was basically rebuilding the model digitally in engine. I'm sure there's a more automated way to do this, maybe some kind of script, but that's a challenge for another day. Annoyances aside, the stress test is over and the system works. There's a workflow in place that gives us a foundation for any Lego to make its way into this game, with function and life. And in the end, the result is worth it. Reactive and destructive Lego goodness. When you strip a game back to its basics, it often comes down to getting from point A to point B with obstacles in the way. And in the case of a Lego game, it's no different. One of those obstacles is the enemies you encounter. If I'm going to deliver on the feeling of a Lego game, I'd better get to work on some combat. Our next piece of modular logic is for attacking. And the great thing about driving combat through an act component is that we can apply this to more than just the player. But for now, let's take our 2 attack animations we made earlier, Punch 1 and Punch 2, imaginatively named, and turn them into a combo that can strike Lego and enemies alike. The attack is going to come from the same button, and we want the attacks to alternate. By using an integer to track how far into a combo we are, we can use that to select which animation montage to play next. So press attack once and combo attack 1 will play. The combo tracking integer also goes up by 1. Once the combo integer reaches the maximum number of attack variations, it resets back to the start. By doing it this way, it's scalable. If we want more attacks, we can comfortably slot them into this system. You might think the animation montage is just a visual difference, but it also controls timing and even logic. There's 2 key things happening when a player attacks, and both of them are called within the montage. The first is a launch. Right now that's a short push forward, giving the attack a sense of momentum, but when it comes to a Lego game, it does much more. Lego games want you to have fun. They want you to feel good at the game, reducing frustration by quietly giving you a helping hand. Most, if not all, attacks in Lego have a light lock-on system whenever a player attacks. You want to strike that enemy but you're a little further away than ideal? No problem. Or maybe you're not facing the exact direction? No problem. We'll get you there. You just have fun. That's the philosophy. And therefore for this project, it's also mine. To do this, I need to know if there's something hittable in front of a player, so I run a sphere trace for the Lego objects and characters, and it has a radius so there's some forgiveness in its accuracy. The goal is to help, not hinder. If we do hit something, then we want to adapt our launch. We should instead launch from where we are towards the hit target, and we can calculate that launch velocity as an arc. There's some experimenting with the values involved, but now we're helping the player play at their best. We're doing it the Lego way. But what about enemies? Who are the enemies? That brings us to the second part of the montage setup. It's probably time we gave our earlier abandoned health actor component a real purpose. The health component becomes the shared way characters take damage, recover health, and know when they're dead. I want to visualize health using the classic Lego Hearts HUD, but admittedly I did also get distracted and create the profile icon. I even found a font similar-ish to Lego's and did the flashing text to tell you what character you are. But getting back on track, whenever health changes via our component, the HUD will update automatically because of dispatcher calls. It's simple and reliable. But unless this bench is going to become sentient and start attacking me, we need some enemies. This Lego set in many ways is my asset pack. And if you've watched any of my other videos, you know I like to be resourceful with my asset packs. So the enemies are going to be elves, but they are red, so you know they're not nice, and it's definitely not copy and paste, because they're red. Don't call me lazy. Unfortunately, it isn't copy and paste, because whilst we can press a button to make things happen, AI can't. Well, not yet anyway. What makes the best AI in a game? Some may say intelligence, but I think the best AI is the one which makes you feel the most rewarding. I think in Lego's case, it's an AI which presents minimal challenge and maximum smashing. Let me mash this button and see parts fly. Is it smart AI? No. Is it fun? Yes. Which one is more important? So with this in mind, I'm keeping the AI simple. When the enemy spawns, it targets the player and constantly moves towards them. Once in range, it can then run an attack task on the behavior tree. Like I mentioned before about us pressing a button to attack, this is the AI doing that. It's met a condition of distance to the player, and so it's calling the attack event and doing the same thing. The same hit animation, launch, and sphere trace. And if it hits, now that we have the health actor component set up, we can access that and ask it to update the health. Very simple AI, but I feel a basic level of threat from them, enough to take action, and I get to smack some minifigures around and feel like a big strong elf. I'm happy, you're happy, that elf over there isn't happy. He's an angry elf. Now if you do die, the health component fires off a dispatcher, an alert, which the characters can respond to in their own way. But for now, for both of them, they simply get destroyed, which I think we can all agree doesn't look very good. So it was back to playing Lego games, for research obviously. I don't sit playing Lego games all day, like this is all for, oh sick, a mini kit, which is excellent for research. Playing, recording and analysing the combat of Lego The Hobbit did two things. It showed me how Lego handles character death in a more satisfying way, but it also made something else very clear. What we have is a foundation to work with, but if this is going to feel like Lego, there's a lot more work ahead. Do me a quick favor and subscribe. No, that's not actually what I was going to say, but yes, you should do that. No, do me a favor, think of any game where you enjoy the combat. You picturing it? Okay. Now imagine when you hit an enemy, it didn't do anything. There was no visual indication, no knockback, no reaction animation. That top tier combat you're imagining is probably half as good. It's half as responsive, and I believe that's the key word, responsive. In games, I define it as me taking an action and getting the result I expect. For example, I press attack and an animation plays. That is a response. If it looks like I've hit an enemy, then I have an expectation for them to react to my action. And if it doesn't, it feels like my action didn't matter. There's no response. That's where we are right now. And it's exactly what Lego does with their combat. I'm going to create a hit reaction animation to help meet the expectation that hitting an enemy should actually feel like a hit. We can play this animation whenever the enemy's health is updated. Alongside that, we can stop movement and apply a launch based on the damage instigator's forward vector, which in this case is going to be me and my mighty punch. Now we have a physical reaction through the animation, a change in their movement, and a physical change in location, all from our hit. I'm starting to feel like my actions have a response. We've still got that boring death though. A simple destroy actor will not do. There needs to be a visual reward, a satisfaction in defeating an enemy. So utilizing the systems we set up earlier, we can spawn one of our destruction parts blueprints to spit out minifigure meshes upon death. The combat right now feels like a big step forward from where it was. Is it at Lego's quality level? No, but it is more responsive, it is more satisfying, and we're not stopping there, because there's a new problem. From having to fight so many enemies over and over, I can't help but make comparison with Lego's combat, and much like the issue we faced with the destruction, I feel there's room for more personality, more charm. Should I be spending more time on this? Probably not. It's fine as it is, but if I'm going to bring a Lego set to life, I feel it needs to be done right. So yes, you guessed it, I'm back to animating. This time, a death animation for the character, and once again, I'm using my gameplay references to help guide me. I also noticed something else which I really like. It's the reaction of the enemies after you've been defeated. They celebrate. This is the character and charm I'm speaking of, but I think this cleverly goes beyond just fun animation. There's a reoccurring theme with what Lego does. They aren't there to challenge you. They are there to let you embrace the fun of it all. So even when you die, I have a theory that the celebration animation is doing something more than just taunting you a little bit. It's giving you a natural window of opportunity to get back into the fight and get the first hit again. You go from a position of loss to winning again very quickly. It's all just a theory, but game design is made up of all these little decisions that come together to create an intended experience. So I like to think this is a conscious decision. A good opportunity to both hit the enemy back, or to go get your studs back. To get your studs back. Studs. I thought saying it enough might make studs just appear. But fine, I guess we'll move on to our next piece of the build. It's everyone's favourite part of a Lego game, the studs. Or maybe it's not the studs. If only you had a way of letting me know what your favourite part of a Lego game is. Oh well. In case you've lived under a rock for the past 25 years, studs are the currency of a Lego game. Plentiful and addictive to pick up. Every last one of them. With the idea of trying to capture a genuine feel for our Lego project, it makes sense to make the studs accurate. So accurate that I'm going to use the actual Lego stud sprites from Lego Star Wars. Whoa. Editor Torch speaking here. Whilst past me has a fair point, we are going to change the studs later on in the video, and you'll also see why. Hello, my mic just stopped working for a second. Anyway, I've never done anything with sprites or flipbooks before, but the process was pretty quick, and now we have the studs spinning in the level. The good thing about having a flipbook is that I can set it up as a material as well, and then use it in the UI elements. One of them is the stud total, which will display in the top left of your screen, and will tell you how rich or poor you are. The second is something I've called the stud to total stud. When you pick up a stud in any Lego game, it very smoothly floats off towards your stud total in the top left. I need a way to go from where the stud is in the world to the top left of the screen, repeatedly and reliably, no matter where the stud is picked up. Playing Lego games wasn't helping me much to understand, so it was time to put the controller down and have a little think about it. I've got an idea. What if we go from world space to screen space? Then from that screen space, lerp over a fixed timeline to a fixed screen position like the top left. That would work, right? Well, it turns out I'm in luck, because Unreal Engine has a node for converting world space to screen space. So when I pick up a stud, I can get its location, pass that through the magic conversion node, and then tell the UI element to set itself to that position. A sound concept, but clearly something isn't quite right. I assume this is because of the viewport size and we need to maybe divide it by the viewport scale? And I was along the right lines, but eventually after a bit of googling and good old-fashioned trial and error, it worked. I had to do the viewport scale but inverted via a power node, and the stud needed to be anchored in the top left. If you think I fully understand why this works over anything else I tried, you'd be very wrong. I don't fully know why, but it works. It works reliably as well, so I'm happy, you're happy, and that elf is still not happy. And fear not, I have not forgotten the detail of having the stud total reflect the colour of the last stud you've got. So when you get that sweet, sweet purple stud, we'll know. We'll know. Oh wait, hold on, I've forgotten to do something. Sorry, you can fade out in a second. We need to make the studs bouncy. I grab a cube, add it to the blueprint, make it simulate physics, but only in its location, not its rotation. Then I'm going to add a bouncy physical material to it, offset the stud so it's always off the ground, and now they bounce. Okay, you can fade out now, sorry. I think it's about time we start rewarding the player with our new creation. Now that we have individual studs and the framework for adding them to our total, we need a way for different events to spawn different amounts of studs. And like everything in this game, it needs to be a piece, a brick, something we can place as and where we need it. You may have guessed it already, it's time for another actor component. Every action should have varying degrees of rewards. If I go and build a larger object, I expect a decent amount of studs. If I hit a small object, I expect a smaller amount of studs. I'd like lots of them, but I don't expect it. Whenever there's options, I often fall back on something called an enumerator. It's a way of setting up options as a variable. In this case, we're going to call our options low, medium, high, and ultra, all of which are representative of the amount and quality. So we have varying degrees of reward thanks to our setup being driven by an enumerator. We now need to be able to apply this to most actions, but because it's an actor component, we can. We can add it to our objects and call the stud spawning events from the component when the object is built. Well done for building. Did you just defeat one of Santa's little rebels? That's a good name. I'm gonna use that. Well, no worries, we'll put this component on our enemy characters, and when the death event dispatcher is called, we'll ask the stud component to spawn some studs for your hard work. And we'll set the reward to low. I envision you may destroy quite a few elves along the way. Another fine addition
to my collection
to the system we're building in this project. The pieces are coming together, and I'm liking where it's going. But we're not ready to move on yet. We've missed something. Lego doesn't just drop studs, it breaks hearts. Wait, why are you playing sad music? You said it breaks hearts? Did I? Because we have a health component with our events already set up from earlier, we can easily restore health. So the main bit of work we need to do is to create the heart model. It's not a Lego piece, so we'll have to make a custom one in Blender with a Lego heart image as a reference. Put that into an actor and then hook it all up so the overlap gets the health component and restores the health. I'm also going to set up the fade out function, which we've been using with destroyed Lego pieces. That way the studs and hearts which are dropped will eventually fade out, a bit like what were those games called? Lego games. Yeah, I don't feel like I've said Lego games enough in this video. But with our pockets getting fat from all the studs being dropped and our hearts never breaking, it's time to continue our journey into the fifth and final brick. This vaguely titled brick moves us onto the level mechanics. This final piece of our 5 key pieces to make a Lego game includes 3 iconic mechanics. We've just finished putting together our stud system, and now that I'm rolling in the dough, I'd like it to contribute to something. You might see where this is going. True Jedi, true pirate, true adventurer, take your pick. It's part of the feel-good adventure that a Lego level is, and so we need it in ours. I'm going to use Lego's very own textures again, using the same Lego Star Wars sprite textures for now. It's temporary. With an empty bar texture and a full bar texture, I can use these with a progress bar element inside my widget. So now, as we gather studs, we build up our bar. But what happens when we reach for total and the bar fills up to 100%? We celebrate. And the way LEGO does this is by scaling the bar up, then back down again, and having layered text appear and fade out on screen. I use LEGO Star Wars as a reference point. I've tried to recreate the same type of effect, but with this being Christmas themed, it felt fitting to call it True Believer. I really like that as a name, but let me know what you would have called it in the comments down below. And with it all working, I now can't stop picking up purple studs and getting True Believer over and over again. We need to stop though. We've made so much progress and I think it's going pretty well so far. But with everything we've added, we've failed to include the core part of all of this, the LEGO set. The gameplay is built around this, and now that the 5 key pieces are gradually coming together, I think it's time we use the systems we've built to bring it to life. Remember this? We built it right at the start of a project, and now, just now, we're finally getting it in engine, and what a task it is. It's the biggest model with the most pieces, which makes it the biggest test of our LEGO to engine workflow. There are a lot of individual pieces and a lot of organisation required if I don't want to lose my mind. A nice thing about this LEGO set is that it's not just the delivery truck itself. You also get a Christmas tree and a bunch of present variations. These are all assets we can make use of. This in particular feels like a significant moment. It's a new asset that touches almost every part of the pipeline we've put so much time and effort into building. It's set up with destruction, no destruction, building, studs and animation, all in a reasonable time frame. There's still plenty of work involved, but we're turning parts into play. As we've now finally got the LEGO set in engine, it feels like a good time to talk about what I actually envision the game being. We've been so focused on following the recipe for LEGO goodness that I've not really stopped to say where the LEGO set fully fits in. So here's the broader idea, building off from the description at the start. It's Christmas Eve, and you're out helping to deliver presents like the dutiful elf that you are. But you've taken a wrong turn. How has this happened? You never take a wrong turn. The new road ahead is unpredictable and the snowy landscape causes you to crash. You wake up to find your delivery truck broken into pieces. 5 core components of it have been stolen by Santa's little rebels. Your mission now is to explore, fight, and rebuild your delivery truck so that Christmas may continue. Now that we're all on the same page, we can turn our attention to making sure you can actually rebuild your truck. We can rebuild parts into objects, but what if the parts aren't already at the truck? You're meant to explore, which means rebuilding happens further away. And that's the problem. We need to get the parts from A to B, and I hadn't thought about this. But we've made it this far, so I see no reason why we can't put together a quick pick up and carry mechanic. Expanding the object blueprint, I add a boolean to determine whether it can be picked up. I'm also going to set up another BPI event for interaction. When I press interact, I check if I'm overlapping an object, and whether it can be picked up, and if so, then attach it to a socket on my right hand. This translates to mean I can stick an actor to my hand, go walk somewhere else, and then unstick it. Or as we humans call it, carrying. But it doesn't feel like carrying. I think there are a couple of things that can really sell it, and once again, it's another example of feeling coming from the layers on top. The first layer is a change in movement speed. We're carrying something, so there's an expectation to slow down a bit. And the second layer is going to be an animation. This time I have no reference for it, so I'm eyeballing the poses and trying to convey the idea of waddling with something large in your hand. And between these two layers, we now give a feeling to functionality. We give a reaction to our action. Waddling over to the truck doesn't do anything though, so this poor elf is endlessly carrying Lego around hoping for an outcome. Let's give him one. I set up an actor with a volume that checks for objects with a specific tag. If one is detected in the overlap, then the carried object is destroyed, and an instance of the object is spawned in the correct position on the truck. That's the blueprint explanation, but to the player, it looks like you're restoring the Lego set to its former glory. And there's something really cool about seeing it rebuilding an engine while the real Lego set sits right next to me. Now we can return to the collectibles. We've got True Believer, but there's something even more iconic. When I say Lego game, what are 5 things which come to mind? I'll give you a few seconds. Right, time's up. I could be wrong, but I imagine one of them is our next task. It's minikit time. Luckily, I found Studio 2.0 instructions to rebuild an exact 1-to-1 minikit so we can get it in engine. Walk into the actor, add a value to our level tracker, which is tracking our collectibles and progress, and then destroy it. And that's it. Ah, really? Again? Turns out minikits also float to a UI element. Thankfully, we've done this before, so setting it up was fairly painless. That's not a sentence you hear very often in game development. We now have 2 icons of the LEGO gaming world, along with the 4 other bricks we've been building upon. I think we're in a good place right now. And we could stop here. We could, but we won't. You may recall me saying that games are often about going from A to B with obstacles in between, and LEGO is no different. But there's a mechanic often found in LEGO games which takes the idea of going from A to B in a different direction. The small access hatch. Known in LEGO games to only be accessible by the short characters and the only reason you'd play as young Anakin in the complete saga. Yippee! This is one of the few models without instructions. I have to design the hatch myself, but I think it looks alright, right? I'm no LEGO designer, but it works. Yeah, it's fine. While in Bricklink Studio, I had a little look around to see what inspiration there is for the level we're going to create, and I think it's going to look pretty cool. Once I stop getting distracted, I can start to set up the small hatch as a LEGO object, but with an expansion to its logic and components. That logic is going to find the nearest hatch, get its location, and then set the actor's location to it. This works, and on the surface, it is pretty simple. The purpose is to go from A to B in a teleporting fashion, and that's what we've done. But there's a few extra steps to get it feeling like the way LEGO does, and you can probably take some guesses at this point as to what they may be. Firstly, we need to crawl through the hatch, so it's animation time once again. Can you imagine trying to do this project if I hadn't just embraced that I was going to have to tackle the challenge of animation myself? I'm not joking when I say I was close to possibly hiring a freelancer to handle rigging and animation, and I was convinced that I wouldn't be able to do it. Someone else will need to do it. Thank God I didn't listen to doubt. Let's get the hatch doors opening and closing correctly, and we'll add an unlit black plane so it looks like we're entering a dark, unknown space. Ooh, where's it going? It's also set up in a way so that it will automatically work whichever hatch you go through. So we've come out of, a minikit. Okay, now it's starting to feel like a LEGO game. We can build, fight, destroy, collect minikits, get true believer, carry parts, drop them off, go through small hatches. It really is starting to feel like a LEGO experience. And that's because we've built up one by one these 5 core pieces which I believe make up the foundations of a LEGO game. They've complemented each other, they've stacked on top of one another, and they can now create something bigger than the sum of their parts. I went into designing the world thinking that I would do what the classic 2000 LEGO games did, mix a realistic world with a LEGO world. But whilst game development is a very technical and logical process, it's also about feeling. And when I saw a realistic landscape with the LEGO set, it felt wrong. It didn't sit right with me. Maybe it's for texture, maybe it's for lighting, but my instinct said no, and it said it strongly. While searching for visual references, I kept coming back to LEGO Horizon. It's a fully LEGO built world, and there's something really satisfying about that. However, that's also a lot of work. But I know it will be worth it. Before diving headfirst into this new direction, I needed to test it. That meant spending some time as a LEGO designer, putting together a variety of terrain pieces which could fit together. Things like the big tree are designed by other much better LEGO designers. What I made myself, I gave my best shot. Following our pipeline, I could test a small area. Where my instinct previously said no, this small test says yes. It feels right, and I'm excited to start bringing this world to life. I can start transforming ideas on paper into a reality. Let's start with our first area. This space is going to be where you have crashed your truck and start the game. This starting space will be reasonably spacious, but the player can focus on what's immediately around them and get to grips with the game. The plan is to have one mini kit and one lot of truck parts. And to house some of these, let's add a small cabin. To access the cabin, you need to hit the door, so let's get an animation for that. When the door swings open, you'll find a mini kit inside, and parts for the front of the truck will also be released. Each area we mark out on paper should bring something useful to the player, so let's continue our plan. The next area down the path, slightly off to the side, is a campsite. And for that, we're going to need a tent, and of course, a campfire. The campfire will be our first new object that ties directly into the building and destruction systems, which is exciting. What? This time we're going to have the fire not only be animated, but also light up. And I'd really like the light to have a function, allowing it to flicker. It might be Lego, but who's to say you can't immerse yourself next to a roaring fire? I've been placing fences to define areas and block the player, but I wanted to explore something more natural. Maybe some grass. Fortunately, Lego has tall grass. I chose an olive green colour scheme and then decided to take the material a step further. I added subsurface scattering based on a gradient mask, so only the highest tips of the tall grass allow a little bit of light to pass through. Just because we're progressing forward doesn't mean we can't go back and iterate a bit more on the starting area, especially as new ideas come to mind, like this one with the bench. Ever since adding the bench, I've wanted to bounce on it. Does it make sense? Nope. Am I going to do it anyway? Yep. I add a simple overlap volume, check if the character is overlapping, and if so, then launch them upwards. I want to tie this into a bit of a Lego loop. You destroy one object, rebuild it into another, interact with that, and reach a new space. And for doing so, you are rewarded. And it's these little loops which ultimately form a rewarding and enjoyable experience. I mentioned Lego Horizon earlier as an inspiration point, but something which stood out to me besides the sheer amount of Lego on display was the depth of the scene. There was a clear foreground, midground, and background, which creates depth and atmosphere, and generally just looks really nice. But our world so far doesn't have that. It has a flat feeling. Some of this is lighting, composition, and colour, but it is also a lack of background to provide layers. And so, inspired by Horizon, I started to make a fog material, and after eventually remembering the better way of setting one up, it's been a little while, I could apply this material to a sphere and tweak my parameters until my heart was content. I can tweak the lighting to provide more readable shadows in the scene, add a large emissive plane for soft, cool bounce lighting as a backlight, enable volumetric fog, and eventually we start to see a sense of depth. You can start to see something that feels visually richer. Feeling more confident with the lighting and overall presentation for the world, we can return to our pen and paper as we explore new ideas for the third area. I know I want to make use of the small access hatch for this space, but I wasn't sure how to smoothly integrate it into it. I really like the idea of it feeling like it's taking you to a whole new space, something familiar but clearly its own area. Again, I find myself saying, that's a lot more work, and I get the feeling I'm going to keep saying that, but also keep doing it anyway. I'm going to follow the same formula we used with the bench, destroying one object to rebuild another, but this time it's a small hatch. But with all small hatches comes mystery. Hold on, where have those enemies come from? Ah, right, yeah, 1 second. We need enemy spawn volumes. We could just place enemies directly into the world, but the problem is that the AI is set to eternally chase the player, so as soon as you start playing, you will be hunted. So it makes more sense to handle this with a spawn volume. This is an Exa with an overlap volume, because games are built on overlap volumes. That really sounds like the kind of sense which needs to be on a shirt. But in this case, it rings true. When you overlap with the volume, an event will fire to spawn enemies in a small radius around its location. But we don't just make logic, we make systems. So I exposed a few controls. How many enemies to spawn, whether the volume can be re-triggered, and how long its cooldown should be. Now we can place this volume anywhere and cover most of our basic spawning needs. In the spirit of revisiting, let's give the player a reason to check out the campfire area we made. And I see no better reason to stop your journey than a mini kit. When I think of campfires, I think of food and cooking pots. So I want to do something with that. You rebuild the campfire and it comes alight. Once it's alight, you can pick up the pot and walk it over to the campfire. This makes use of our carry and drop-off volumes. Once added, logic inside the campfire reveals an animated cooking pot that moves up and down, jump on top, and rise to your heart's true desire. It's another neat example of using the mechanics and systems we've developed to create a very light puzzle element. Lego games are full of these, simple, engaging, and rewarding. But you will still need to fend off a few of Santa's little rebels. You are entering the campsite after all. With the level getting bigger and bigger, my attention kept bouncing around each area. For example, I started adding candy canes, barrels, and turkey legs to help bring some more festive destruction to the playable area. I was also continuously developing the terrain further and making tweaks to little imperfections I encountered. But there's only so much tweaking I can do before my attention must turn to the final area of the game. And to get there, we need a gateway. I found this cool gate design, cleaned it up a bit, changed the colour scheme to fit the wintry landscape, and then got it in engine. And now, with a gateway in place, a new question comes up. Where does it lead? Earlier on, when I was looking through Bricklink Studio, I found this model of a winter cabin. I also saw how many pieces it was, and thought, maybe, we'll see. But here we are. We've come so far and done so much. It would be a shame not to add it. And it seems very fitting for a final area in which you get the final piece. So I got it in engine and started to build an area around it. The lighting and composition are all designed with the house as the focus. Let's be honest, you look at this winter cabin and you want to go inside. So do I. I set up a level transport blueprint. This will set your location while also loading and unloading sublevels depending on whether you're entering or leaving. You can now walk through the doors and be taken to the interior. And here, you'll find the final piece of your truck. Except, I made a mistake. I forgot how to do simple maths and miscounted how many parts I actually had. I thought I had 4, turns out I had 5, so we need to do a bit of reshuffling. To keep truck part acquisition evenly spread across the level, I'm going to move the campfire minikit sequence over to the winter cabin area, and then put the missing part of the truck's back door here. This area has become a trial by combat encounter, rather than a light Lego puzzle. And now we have a level in which you can gather all 5 parts of a truck from the different areas. Areas that we originally mapped out on paper, but through time, systems, and commitment have now been built. Listen carefully. Can you hear that? It's deafening silence. A silent game is a game failing to fulfill its potential. Audio and music have the ability to take every element of a game and lift it to a new level. So we need sound and we need music. But I hesitate. My first thought is to go get my hands on some of the iconic LEGO sounds that fans of LEGO games have become accustomed to. But as I'm finding these sounds online, I begin to question it. I'm aware that making any kind of LEGO fan game carries with it a risk that the game itself, wherever it is hosted, may get taken down. There are fair play policies that can be followed, but nonetheless, it's a reality that it happens, and I accept that. But I've used LEGO's actual stud sprites for my studs, the UI elements, the true Jedi bar. Why is the sound making me stop? I've wanted to make a LEGO fan game for a while now. They hold a special place for me. It's partly nostalgia, but it's also the style of game that they are. They're simple but charming, easy to pick up but difficult to put down. They bring people together and say, go have fun. And with this project, I came to a realization. In my journey to try and capture the feeling of a LEGO game, I'm also wanting to capture even just a fraction of that magic for you. If what I create gives even a small amount of that simple, precious fun to someone, then I believe I'm probably doing something right. And therein lies the reason behind my hesitation. If there's anything I can do to increase the chance that this can be played by you and by others, then I'm going to do it. But we now have a new issue. I'm a huge fan of Uppbeat, but understandably it doesn't have much in the way of specific LEGO audio, and I want authentic clicks and snaps, so I only see one option. And once again, it's a lot of work. I'm going to try and make the audio myself, or at least as much of it as I can, and then I'll use Uppbeat to layer any needed additional sounds. And so that's my plan. I captured audio with real LEGO, cleaned, organised and edited it in Audacity. For quite a few sounds I layered various additional things such as thuds, swooshes and bounces, and the result, well, I'll just let you listen to it. I have limited experience with sound and editing it. Honestly, I don't really know what I was doing, but I really like some of the sounds. There's a very authentic clicky soundscape to it. I might have made my own sound, but I'm absolutely not making my own music. Thankfully, Uppbeat has a lot of really great Christmas music. A couple of tracks in particular fit very nicely. So I repeat my question. Can you hear that? That's the sound of a Lego world coming to life. With this big first step in a Lego free direction, I went ahead and started cleaning up. I made sure there was no Lego branding on any of the pieces I used. I made mesh-based studs with a rotation animation and shiny metallic materials. I rehooked all the logic to work with the new additions and created a new flip book for the stud-based UI elements. And I recreated the True Believer bars, also using the new stud-based mesh. I didn't realize this until the very end, but I even went and changed the heart icon, so I remade a simple one and put that in the UI. The word Lego isn't used anywhere in the game either, and now I feel a bit better about this. Again, I'll accept the outcome, but I would have kicked myself if I didn't at least do what I could to give the game a chance. I continue for many more hours on the journey as I create a main menu with a live background of Santa's little rebel stealing your parts, option menus for tweaking graphical settings, an intro sequence to set the scene, and in contrast, an end game sequence to wrap it all up nicely. I tested the game over and over and over again, looking for little imperfections, some literal ones like holes in the floor, but others were about refining the experience. For example, when carrying back the last part, it's a bit of a long walk and there's really not much going on, so I modified the spawn volume with a checkbox for only spawning enemies if the player is carrying something, so now your journey back might get a little interrupted. Another example is hiding valuable studs in a few sneaky places, but that's highly classified information and you'll have to go look for them yourself. I just kept going. Even after hand placing every Lego object in the world, replacing all of Lego's assets, and creating original audio, I kept testing and tweaking. Because I set off on a journey to create a Lego fan game. Not just any game, not a game with a Lego skin. One that feels like Lego, and one that turns a real Lego set into a fully playable game. Building a game is building Lego. You're bringing pieces together, some simple but effective, some are complicated and unclear. You make mistakes, break a few things, but with perseverance and a bit of guidance, you can create something to be proud of. The reward is the final build. And the final build is a lot of fun. Fun which, hopefully, fingers crossed, you can go play for yourself completely free. You just need to head over to itch.io and download it. The link is in the description. I genuinely hope you have a great time with it. If you're still here after such a long journey, I'm going to assume you somewhat enjoyed it. And if you did, remember to hit the like button. I know you're probably sick of every single YouTuber telling you to hit the like button, but it really does help. For a smaller channel like myself, it helps to put this content in front of people like me and you, and so I win, you win, they win, we all win. Make sure you comment down below if you want to see more content like this video, your thoughts, your feelings, your ideas, and make sure you're subscribed for what's coming in 2026. You don't want to miss it. Thank you so much for being here, and I'll see you next time.